because I can stream with everything. Like, Quiet down, everybody. Okay, everyone, quiet down, please. Por favor. Wait, I think they're like working on. Time to set the speaker. Wait, I'm live right now. So we're gonna get started with a software workshop now. Excellent. So yeah, here's a list of the workshops we have. So we already completed the CAD workshop, computer aided design, and the mech workshops, which were like 3 weeks and 2 weeks ago. And this is the programming workshop. And next year we're going to have the not no. Next week we're going to have the non-technical and the outreach workshop. So yeah. Okay, so a little bit about software. Intro to. So this is the agenda for today. So we're going to start with a rundown and how to set up things on your computer. You guys should have like set things up on your like downloaded and set up the things on your at home. But it's okay if you haven't like completely done it or if you got stuck at any step because we'll be doing like a rundown with all the steps. So this is like an overview of the apps, the libraries, and the hardware you need for your robot, and also like the importance and role of software during FTC matches. And then two, we're going to be going over some really simple driver code. And this is very simple code to like how to program your robot. And it's like the bare basic. And three, we're gonna go over autonomous after a short break. So the first part of autonomous is going to be localization and motion planning, which is basically like how the robot moves. And that includes libraries such as Roadrunner and concepts such as odometry. And four, we're going to go over vision, which is like computer vision. And five, we're going to have a hands-on activity at the very end where we're going to go over how to program your own drivetrains and also how to program flaws. Okay, so brief overview. So as an introduction, software is one of the three components of FTC, right? So the first one is mechanical, which also includes CAD. The second would be software, and then the last one would be like all the non-technical stuff like outreach. And it's really important. It really stands out in the 30-second autonomous period, which at the very start of any FTC match, there's a 30-second autonomous period where it's completely it's pre-written code and it's not operated by any humans. And and then during the rest of the match, which is 2 minutes and 30 seconds, there's a tell period. And code is most commonly written in Java in Android Studios, which hopefully you guys downloaded already. There's also an alternative option called Blocks, which is similar to Scratch. It's block coding. It has its ups and downs, but it's kind of less competitive, but it's really beginner friendly. Okay, and here's a video of an example time. Can I freeze? Is that silence? So this is like completely robot control and no driver, so it's pre-written code. No. FTC is like a bit different from BattleBox, so you aren't like actually trying to defeat each other. So yeah, this is like one of the world's best teams called Hyperion on the very bottom. Wait, that's one. Yeah. Yeah, that's not empty. Oh, it is. Yeah. So as you can see, that was 30 seconds, and now the drivers are picking up their controllers, like at the bottom. What's going on? Okay, so this is like a lot of info, but this is just like a general overview, and I'm going to go through each of these in detail at the very end because this is vision. But basically, there are external libraries and resources in FTC2. So you don't have to code everything because that'd be really hard. Also, all the vision would be really hard because we use stuff like TensorFlow, which is a light version of Google's vision identifying software, and Easy OpenCV is another example. And for motion planning, we use Roadrunner, which was built for FTC. And so, yeah, these are a bit of the libraries that we would use in software. Okay, so control systems in FTC. So in when you're using software, you're also going to need some hardware elements on your robot. So in the FTC control station, you're going to need an Android phone and preferably two robot controllers to control the robot and also connect to the control hub. And the control hub is mounted on your robot, and it's also basically like an Android phone, except you can connect it to a bunch of hardware stuff like motors and also the battery, sensors, cameras, and anything else you need on your robot. And yeah, so if you guys have downloaded already, the FTC SDK is what's provided by FTC, and there's a new one released every season. So the ones you guys downloaded is probably from the last season because that's the recent one. And then op modes are they're short for operation modes. I'll be going over those in a second, but they're what you're supposed to write as a team. And so once you write those op modes, which I'm going to go over a job, then um, you put it onto the control hub, and then you connect it with the driver station. And so yeah, basically everything else is provided by FTC, and all you have to do is write those op modes. Okay, so hardware elements, going back in, here's like a list of the hardware elements that you need. So like an Android phone and the driver station. Technically, you could get away with using an Android phone, but a lot of teams use a driver station. It's also like similar to an Android phone, except it's made for FTC. And there's the control hub, which is that thing. It's going to be mounted on your robot. There's also the expansion hub, which is also connected to the control hub, but it has more ports, and you would also need wires, sensors, and cameras. Encoders, motor encoders basically measure how much your motor has turned, and odometry, which I will go over later. So yeah, Android Studios VS Block. So I talked about this a little bit earlier, but basically Android Studios is all in Java, and it's used by most competitors because like it's really easy to integrate external libraries, and also like it's really good to use with FTC dashboard and other stuff. But the cons, as you may have experienced, is that the setup is like pretty hard, right? You have to download a bunch of stuff, and you also have to like update the SD, like you have to update a lot of stuff. And it can be harder to debug, and you also need some Java knowledge beforehand. And Block's programming tool, it's simple and convenient to use for new teams. If you don't have that much coding knowledge, Blocks, if you've tried Scratch before, it's basically like just logic and then you click the blocks. So that's pretty easy. But the cons are that it's not used often because it's like limited in usage, and it's harder to use external libraries and stuff. Okay, so for those of you guys that had any problems like downloading these materials or like going through the setup process, we're going to go over like an overview For those of you guys that already finished this, however, do note that this is like a pretty important process, and if you ever need to like teach any of your other teammates anything about the process or like other people in general, then this should be pretty important. So number one, obviously, you have to download Android Studio, and then you have to download the current or most recent season's SDK, and that's provided by FTC. And then you have to add dependencies, and then you have to add ADB, which is used for connecting to the robot. Yeah. Okay, so down. Can I get a quick show of hands? Like, did anyone encounter any problems, or did anyone come without like these things downloaded? It's okay if you raise your hands because we're literally going over it. Okay. Yeah, I know. Okay, so for those of you, has anyone not downloaded Android Studio yet? If you haven't, go to this link. If you can see it, it's developer.android.com. Or just like search up Android Studio in the down.
We need you will not need an Android to design.
Oh yeah, it's gonna take a while. Outreach. It's gonna take a while. Wait, comment. Can you go home?
Like, you need to take a while. Take a while to set up.
I'm not sure how possible to upload.
The Wi-Fi here kind of gone. So I don't know.
We can try downloading it the library Wi-Fi right now, but chances are it's gonna be slow. So for those of you that haven't downloaded a majority of these, uh, so chances are this is going to take some time on the library Wi-Fi. So if you haven't downloaded or done a majority of these, it might be a better idea to just like listen in and at the very end, when we're doing the hands-on activities, we're going to split you guys into groups. So you don't really need everything. Not everyone needs everything set up on their computer.
So he has a question. He downloaded Android Studio after he downloaded his the platform SDK from in the past. So is he making some package with the download?
Like if you download this like Android Studio, it should just have it with it. So maybe he downloaded the wrong version.
Should we ask him to?
I mean, if he has everything else,
So that message should be there because of if not active.
that's completely different. Okay, you can wait a little.
Right. Right. Sure. Sure.
Anyone still going like downloading Android Studio?
Fix this, bro. Do you have the code for the claw? Or
Yeah,
they're gonna code the claw?
contract.
Oh, I see.
Okay.
I should have positions are correct.
I'm gonna make them reset conditions and then figure it out for themselves.
Okay. Well,
But this is all corporate. All the servos are different thing, right?
no, they're all towards their game.
That's actually good. What? Yeah.
Maybe football.
ADB for connecting to.
Usually we use, so we've got it right there that has been included. We use the USB-C cable.
Yeah, that's fine. But working there prefer ADB because it's like a lot easier. You can just like open it up on the computer and type like ADB connect. But yeah, USB.
But it really seems to be on the base that you send us. It seems to be for the new radio with phone.
Yeah, no, because the controller actually basically does an Android code
Yeah.
with it's like a mounted Android code, so it has an Android.
Oh, got it. Got it. That's what they're referring to as Android phone.
Yeah.
So we set up ADB on my laptop. But if I just add the path, I should be able to just use ADB connectors.
Yeah.
Okay.
Yeah.
Instead of the studio.
You do also need to connect to the Wi-Fi.
We already did that.
Yeah, then it's good.
The Wi-Fi. Well, the Wi-Fi of the control hub is connected to the drive,
Yeah.
right?
Yeah.
Not to the laptop.
Also the laptop. Actually.
Also the laptop.
Yeah.
Okay.
It's,
I think we didn't do it because we're using the USB-C connection.
yeah. I'll be going over that too.
You'll go over that?
Yeah.
Think that I would change for the afternoon. Don't actually have to tight on.
No, this is temporary. So we know we're going to build a robot. We just drive for here. Otherwise, when we drive, it will
Think actually get right. You guys have are you planning on mounting it? Like yeah. Like
we mounting what?
this. Like you have to use like
Okay, be moving on now.
Wall, back.
yeah. We're gonna keep the battery
Slow.
lower and then put it on back.
Heavy.
Anyone have to spread out. I'm gonna try to wait for
Okay,
it.
so
After.
does everyone have the FTC as? Can I have everyone's attention? Can I have everyone's attention, please?
Everyone, can we listen to Ethan speak? Thank you.
Okay, so we should be familiar now. So the everyone have the SDK, the FTC SDK. Basically, it's a GitHub link, and then you turn on the stream audio. Yeah. Okay, good. Yeah, for anyone who hasn't done it yet, just basically search up FTC SDK, and then yeah, go to code and then download it. So it should be pretty fast. Is there anyone downloading it right now? Okay. So if you guys, so the next step after that, so can I have everyone's attention, please? Okay, so basically after you open the file for, then you open Android Studio by clicking import project, and then uh, you click on the top and controller master. Yeah. And then so when you want to create content, Android Studio, on the very left side, and under the menu, there's the PC robot controller. There should be a section called Team Code. Team Code, yeah. And then if you go to Team Code and then source main Java, that is where everyone's going to be writing their program. Yeah. So
Can you guys quiet down for a sec? We're gonna continue the presentation. He's gonna like explain how to navigate their Android Studio. So if you guys quiet down, that'd be greatly appreciated. Thank you.
Okay, so building the program in Gradle. So you actually only have to do this every time you add a dependency or something. Top of the screen. It's like it looks like a hammer, and whenever you press that button to build, so it does require you to like download. It does require Wi-Fi, so
There are some people who do not have the build button.
Oh wait, yeah.
Wait, yeah, what version of language? I don't know. Do any Android still like I don't remember because that's like flat.
yeah. So we try to break file, which is yeah, we're going to
They don't see the thing.
Wait, actually, what's the first try? It's on the code for the restart the laptop or video intro, and I'm sure that'll be solid. Yeah,
isn't this the new version? That might be the new.
It still doesn't show up for some.
yes, but it has
Still
to have
show
to
up.
have what's going on your laptop. I have to restart.
You have to reinstall it.
Yeah. Or first,
Just
maybe
just tell them.
tell them to restart the laptop first.
Okay. So if you guys don't see the build option, great. Apparently, if you restart your laptop, there's a chance that it's going to appear. So I suggest restarting your laptop first. But if that doesn't work, you probably have to reinstall Android Studio.
Yeah, I think that's.
Wait, which code do you have to copy?
Oh, we don't have to copy any code yet.
Oh, wait, so what are we doing?
Oh, we're learning. We're going through the setup process right now. So yeah, that's the build function.
If time push code to the control book to like sync the grade.
No, you don't have to. So you don't have to to build it every time you push the control button.
Log in.
Also, so when you update a Gradle file, you need to build it. So Gradle file. So if you're ever using an external library, you're going to be changing the Gradle files at the very bottom. For example, like Roadrunner, you're going to have to implement something. So that you would be adding the dependencies, which I'm going to go over in a second, which is part of the control files. So after you add an implementation, like add a dependency, then you have to build it. Yeah.
Libraries like for outside the program, you have to add it in one of the Gradle dependencies.
Usually, yeah. Unless it's like already in the FTC SDK. Yeah. So yeah, this is adding dependency. Basically, when you want to use external libraries in FTC, like Roadrunner, you can add a dependency to the very bottom. It's in build.gradle, which is another file. And it can be used, dependencies.
See this?
Yeah. Wait, Ethan, can you like share your screen through your video? And I think that'll work. I think that, and then just explain as you do it. I think that'll make more sense.
Let me open up my inner that'd be easier. So this is like the time in build.gradle. That's actual Tinka. You have to add this line, which you should have received in that we sent out to you today. So, does anyone need help setting up the dependency, the repository part? Yeah. So we sent out an email earlier. I sent out an email. Yeah.
Wait, I can just like point out like I think with like you know, like things you have the option. Yeah, I don't want people like actually go to it. So like, no, it's fine.
Just have to go to the setup process, right? Yeah.
So that's pretty nice. Yeah, right. Got it. Just follow that. How's your
So it needs this section should not be there, right?
like all this stuff? So much people like a screenshot back and just throw on the controller and there's like a stream there.
Oh.
It is in the streams.
Did you receive an email? Yeah, we sent out an
Preferred hospital. That's crazy. How you?
yeah. Then
Very like you can have guy is figuring out why his computer is frozen. So not everyone's done. Are there any questions? No.
Okay, I'm gonna assume we're done.
Fortunate. Bro's like, okay, yeah, I know it now. That's crazy. Okay, we can move on.
I think this is the last step, which is a reposition. It's taking like a lot longer than the master. But adding ADB. So ADB is a tool developed by Google, and it's used to debug and test software on Android phones. But in FTC, we usually use ADB to connect to the control hub. And if you haven't installed it already, there was a link in the email that we sent out that explains how you can install ADB on your computer based on your operating system.
Are you seriously gonna teach her how to connect to we're getting okay, first of all, do we have the USB key? Do you have the USB cable card to that? Do they have wait, do you have USB cables?
We use it.
No? Do they have yes we do. We do you do need a USB cable to use it.
They don't. We just need to connect to the Wi-Fi.
You need to connect
It should work.
physically. Or anything over.
No, just run ADB Connect 192.168.
Like it's like
Okay, so does anyone need any help setting up ADB? This is the last step.
I should like
Okay.
just better. What's face like slightly I'm just like, it's, yeah.
Does anyone need any more help?
If I'm still connected.
Okay. Is everyone done? I think everyone's done. I see a hat. Like we're done with the setup process, so we're gonna go over some actual technical stuff. So you guys, the following code that I'm going to show you guys won't be copying over onto your Android Studio. We're going to be typing some stuff at the very end. But for now, we're going to be going over to our next section. So, oh yeah, last thing, Git. So Git is used for version control and also collaboration with people. So it's like really widely used. It's really popular. It's really reliable. So I really recommend using it. And yeah, there's a setup process. You can like use it with Android Studio, but that's like there's a lot to set up. There's a lot to learn about Git too if you aren't familiar with it. So we're not going to go over that right now. Okay, so section two is driver control. So that's the driver control period that I talked about at the very beginning, right? So it's controlled by people with controllers. And so when you want to code in Android Studios, you're going to be coding things called op modes. And modes are short for operational modes, and they're used to control the robot. Uh, Actually, there are two similar types of op modes that are provided in the FTC SDK, but you probably won't have to worry about it. There's linear op mode and op mode, but I recommend sticking to op because apparently it's like a linear op because apparently it's a tiny bit fast. And the robot controller executes op modes during a match to perform tasks like lifting an arm, basically anything. So you put all your code in these op modes. And you can use op modes for basically three main things, right? You want to read inputs from hardware on the robot, so like sensor. You want to do some kind of computation, maybe based on those inputs. And then with the op modes, you want to control parts of your robot, like the motors or the servo. Okay, so this is just like a brief overview. You guys don't have to like remember this, but because we'll be providing the slides at the end. But basically, basic commands in Linux include, so there's the run op mode file, which is the class fire, the function, and then you have various other commands like wait for start and off mode while off mode is active, which are used in the off mode. So that's like the general structure of op. Okay, so hardware map is also a really important thing in the post. So hardware map is the objects, it's a built-in object where you receive hardware from your robot, and you use it using like the name of the hardware things that you set up in the configuration, like during robot configuration. What? Yeah, and that's just like sort of problem. And so if you want to use motors in your code, one way you can do that is using the hardware map. The function is like hardware.get. And so motors are used in like a lot of stuff in FTC, like drivetrains, slides, and a lot of mechanisms. And most motors have a built-in encoder, which is basically used to measure how much the motor has turned. And it's calculated, so the unit of measurement for these encoders is ticks. And another important part to note about using motors is that motors are going to have like a built-in direction. So they have a default direction, and if you want to change the motor direction based on where they are on your drivetrain, you can do that. You can also do that with a function called like set direction. And for motors, the range of power that you can set to a motor is between -1 and 1, with like 1 being in the positive direction with the most power, and -1 being the opposite direction. Yeah. Yeah, so all these numbers are going to be in decimals. You generally set power using a decimal. Yeah. And 0 would be like slots. So that's motors. So servos in so servos are like tiny motors, but you can have more of them in FTC. But the main drawback to using servos is that they're going to have a limited angle range, and they're going to be less powerful than motors. So you can initialize the servo in a similar fashion using hardware map, which we'll also go over at the end. I'll take a question inside. And you can also change the angle of the servo by using dot set position. So like a motor, the range that you can set is between -1 and 1, and it's proportional to the angle of the servo. So what this means is that if you have a servo that has a limited range of like 360 degrees, which is one rotation, then if you do dot 0.5, dot set position 0.5, then it's going to go to 180 degrees, which is half of it. Wait, I think it's 0 to 1 actually. Yeah. Yeah, I think it's in the range 0 to 1. Actually, I don't know. So you can also use, yeah, I'll take the question. Do you need help or is it a question? Okay. Wait, Calvin. You? Yeah. So motors and servos, right? So another thing in FTC is sensors. So there are various types of sensors in FTC. So there's like a distance sensor, which is used to measure distance. There's a color sensor, which can get like color, but also has like a little distance sensor attached to it. and there's also like a switch sensor, I think, like a button. And so you can also get the sensor from hardware map. As you can see, hardware map is pretty important. And then you can get sensor input, and it's going to vary how you get the sensor input depending on what sensor you're using. So if you can see it on the screen here, if you're using a color sensor, you can do like color sensor dot get normalized colors and then dot blue or green and red. And that's going to correspond to like the RGB colors from a scale from 0 to 10 that it reads. So, does anyone have any questions? Yeah. Okay. And so, gamepads, right? So, during the teleop period, the human operated period, you're going to have two gamepads which you can use to control the robot. And each person is going to have one. So, you can have two drivers. And you can have up to two gamepads as well. And the gamepads are predefined. So, they're like already built in. So, if you do gamepad 1 or gamepad 2, that's how you're going to access the gamepad. They have various built-in functions. For example, if you do gamepad1.x, it's going to tell you if the X button is pressed down or not. And there's also gamepad1.left stick Y, which is like the left stick on the controller. No, it's okay. Is that all? Should we have a 10-minute break right now? Okay, wait, raise your hands who wants to go on and who wants to have a 10-minute break right now. So if you want to go on, please raise your hand.
That's crazy, bro.
Okay, but we basically had a break at the. I'll be going over the like the bit of the autonomous part, and then we'll have a break, I guess. So there are two main parts of autonomous. The first part is localization and path planning, which is basically like how your robot moves across the field. And number two is vision, so computer vision. And first we'll be going over a brief overview of like the localization and path planning. So generally, a lot of teams are going to use this software called, and it's a Kotlin library designed for FTC. And yeah, it's used to plan 2D paths on the plan field. So it can be used for localization, which is to know where your robot is on the field. Um, Trajectory generation, which is like moving your robot, and then control. So motion planning is really useful with built-in libraries like this because the alternative might be like hard coding your movements, which would be really difficult. And the plus to Roadrunner is that everything's like built in, right? So all you have to do is tune it every time you use Roadrunner. And then once you tune it, the robot will move correspondingly. And a quick note about the tuning process. So the first time you do the tuning process, it's like kind of complicated. So it might take you like 1 or 2 hours to learn it. But once you get the hang of it, it only takes 30 minutes. So yeah, tuning is really important. But if you use Roadrunner, it should work really well. Yeah.
Like you change from variable something, or you just like
So basically, if you think about it, every time you change something on the robot, like the weight's going to shift or like friction is going to shift and like all the wheels are going to have different friction, right? So what I mean by tuning is that when you tune Roadrunner, it's going to learn like it's going to attune how much like friction or like how much power you need to set to each of the motors in the drivetrain so that it like moves smoothly and like it moves straight.
like
So there's like a tuning process that's explained on like the Roadrunner website. Um, yeah, it's pretty straightforward. It's like everything's already provided for you. Yeah, it learns by itself. I mean,
You still have to provide some constant.
yeah, but most of it's like actually not that bad.
Optional.
for
No. It's not like
It
machine
doesn't
learning.
by
Yeah.
itself.
It's just like calculations. So basically, it just does all the calculations for you.
So you design.
So Roadrunner is a package, and you download it onto your robot, and then you like run the robot and see what's wrong, and then you change some variables and see if it makes it better. And if it doesn't, then you're doing something wrong.
With the giving Roadrunner reference help his path plan better.
Huh?
You help it like path plan better and stuff.
Okay, so like the question was like when you're providing your these variables, does it help plan the path better? And the answer is yes. So basically, tuning is used for more accurate robot movement, right? The better you tune, the more accurate you're going to be moving the robot. Because with Roadrunner, what you can do is you can tell the you can use functions to move the robot to a specific location. And the better you tune Roadrunner, the more like accurate the movement to that position is going to be. So in the autonomous section, Roadrunner is used to like if you saw the robots on the screen, they're going to very specific positions back and forth, right? And that's with some path planning library.
After a while, there's lots of here before it's finished.
Before. So you have to pre-code everything. And then
0, 0, and then you tell what.
yeah,
Do not change the
yeah. And there are like a lot of ways you can yeah. So Roadrunner continue. So there are basically two ways to approach like knowing where your robot is, right? Which is localization. So you can use like um input from the motors because they have built-in encodes, right? And but the problem with this is that when you use mechanism drivetrains like these, like if you can see on the table, they have wheels that tend to slip. So the encoders aren't going to be completely accurate because every time you slip, it's going to like offset the values by a little bit. And if you're using Roadrunner or something, that could make a big difference. So what a lot of teams are going to use is this thing called pedometry or dead wheels, and they're basically wheels that are sprung, so they're like tensioned, and they're used for accurate positioning of the robot. So you're gonna have like a parallel one and a perpendicular one, and it can keep track of like the X, Y location. And these are like wired to and they're more accurate because they're just gonna be regular Omni wheels, which don't have the weird horizontal wheel. So they're gonna slip a lot less.
Quite unfortunately.
Yeah.
They do not move by program, they just don't move at all.
Yeah, so
Spin when they contact the ground and the robot moves.
basically they're just like kind of there and they're like measuring how much they've rotated. So if you just install it on the robot, when you move the robot with the motors, the dead wheel is also going to turn, then it's going to measure how much it turned. So you can measure how much the robot moved as well. Yeah, the wheel just normally
Basically, what that moves, they usually show the coordinates.
yeah, they're more accurate for localization, which is like the location of the robot. Yeah. Any other questions? Basically, it's like similar to motor encoders, except the main difference is that they're not going to be powered by the motors. And the
I can go on a random.
and the wheels are going to be like straight. Um, yeah, actually, there's when you use the Roadrunner startup, there's it's already built into the Roadrunner for odometry. It's pretty important. Yes.
So is there specific like orientation where you put them all in the middle or on the outside?
Yeah. So I'm not gonna go too much into dead wheels right now, but the question was like, is there an orientation to the dead wheels? So generally, it's better for the dead wheels to be in the center of the robot because that means like when you turn the robot, it's gonna be more accurate. Separate in the center of the robot. And you're generally gonna have one that's parallel to the robot and one that's perpendicular, so you can track the X, Y.
Recommend using two.
So you can either use two or three. We use two, but three is like a bit more complicated, but it's like more accurate, right? But honestly, it doesn't really matter that much.
What?
Yeah, but if you have three, like two parallel and then on either side, and then it's a bit more accurate. Okay, so you don't have to do this right now, but basically, if you do want to use Roadrunner, all you have to do is download the Quick Start and install it into your project. And then whenever you want to use Roadrunner on your robot, you have to tune it, like I said. And then there are a bunch of built-in functions that are explained on the Roadrunner website. And you can do those to do very accurate and advanced tasks, like splines, which are like rotations and movements at the same time. And I'll be showing a video of a sample robot that used Roadrunner during a competition during the autonomous phase. So as you can see here, this robot is like rotating and then moving to the same place over and over again. So they're using Roadrunner to do this. And these were, yeah, all pre-programmed movements because they like tried it out on the yeah. Okay. I guess we can have like a short break right now. And then at the very after the break we'll be going over autonomous vision and we'll be doing the hands-on activity. Yeah. See you guys in 15 minutes.
Real man. Change it. You should eat the mic. Like you put those. Here's the water.
I thought you were gonna pull out the timer, but we pulled out one though.
I cannot believe you didn't follow me. Still have it. I cannot.
Wait, you should stream it on your lecture.
No, please. You have different.
I'm TV kidding me. Do I just like leave it here?
Wait, how do I stream?
I don't know.
Here, go. What? Come on. That's one drives. Damn. Like, hold on. No, no, we do. I mean, you know how that there's a big thing, right? I know.
Which slide up
I
like
can't tell the guys. No.
have to
But what? Listen. Solid dependencies. We anyways. Where is it around?
this is slide.
What's it? Slide and oh god, that's my mouth. Okay, so in defense now, we're kind of weak by minutes. Sorry to get you no change. Yeah, for the shaking plan. Sweet. You are dropping sorry has going. I'm going off on this. Like, we might space me like that is. I think right now I was thinking the door and like my I forgot like that. How many different yeah. Oh, I I I did Actually, we're not even colors. We're background. How am I seeing?
That's pretty.
You like even if the man is not here, yeah, ask him if they started with each other. We're being colors. No, right? You bet. No. What? Sir? No, I'm talking with him. It's 10:15. Yeah, no, I'm gonna like go through the hands-on tech. Like, so I'm gonna like demonstrate how to do it first.
I just want to make sure we can easily change power up. They don't rush full power.
Yeah, no, I can just like change a little bit of the code for
That's
should be
how to change that in.
like I could Dude, is that like, bro, you gotta hop up slide mode, dude. That looks actually wrong.
It looks beautiful.
That looks so wrong, dude. I can't. What does that server look like? Server. You have like the background face around like the duck. Yeah, like if I was, I know two class server just like look please.
Wait, do you have to use transparent?
I should go to the bathroom.
Use transparent.
Wait, how do you use transparent technology?
Just go into the settings.
You can do it. Wait, you can do it alone.
Yeah, just wait. Hold on. I'll show you. Back in the settings. And now you want to open this file and open this file and then like search up how you edit it. Like I want to open this in VS
Wait,
Code.
does that mean you can like add backgrounds too?
Yeah. I think so. I'm not sure about the
Fox.
line. Yeah, it's a bad.
I just forgot. Crazy. You forget you're Invisalign. I should probably go to the bathroom.
How many minutes do I have?
5. I have 22 minutes.
What? Wait, what?
Like, stop it. Under this table. Over here and over here.
Each like subs.
Are you gonna start now? Are you gonna start now? Are you gonna start now, bro? Are you gonna start now, bro?
Wait, I just realized the stream was on the entire time.
I think that's a red bad. That's a good
On that?
No, like on the
Okay.
back.
Oh.
That's the same.
Okay, guys, we're starting.
This is just late, like, not that late, like this.
Even your AirPods look very edible.
Okay, guys, we're starting.
Alright,
Anything else? Okay, Calvin. Can you not block the projector? Yes, yeah.
We prep for your access part 2?
Huh?
The access part 4.
Yeah, you got this.
Right. Just like, dude, how many, like, honestly, like, how many people, like, most people I'll expect. And I don't ask questions that they go, after that. It's fine. It's fine? Yeah, it's fine.
Their fault.
Alright, no, you want to, like, lie down? Okay, no.
No, I'll be right. A second.
Okay, guys, quiet down. Okay.
Side plates from Winners.
Custom.
Those are 3D printed.
So, yeah, so I guess let's go over on, like, second.
Okay, so we're gonna get.
Most of your parts are going to be custom. So I'll talk about that.
Can everyone like return to your seats if you're not already? Thank you. Okay, so now we're going to be going over another component of autonomous, and it's vision. So vision's also really important because it's in addition to stuff like Roadrunner, it's also going to help you
Make this short.
move more accurately. Wait, why?
Okay.
So there are four main things you're going to use vision in FTC. The first is TensorFlow, which is a light version of Google's vision identifying software. It's used to identify game elements. It can be used to identify the team's game elements, which is a game element like you create. And April tags, so they're going to be like placed on the playing field, or they're either going to be. They could also be on like the game elements themselves, and they're used for visual tags. They're used for localization. And OpenCV is we're using Easy OpenCV, and it's an open source vision library, so that's we also use that. And Vision Portal is a control interface used in FTC to like use all of these three at the same time. Yeah. Yeah, they are.
TensorFlow, how would you use that in combination with OpenCV? So like TensorFlow gets info from the camera, and OpenCV does.
So they're not dependent on each other, but you can use them at the same time. So TensorFlow doesn't like really rely on OpenCV to work. So they have different purposes because TensorFlow is going to be like AI. So it's gonna be like machine learning, and it's gonna like you can train it to recognize images or like objects on the field. Whereas OpenCV, you generally just like used for like general vision purposes, actually.
Straight TensorFlow, like
Yeah, so that's like so if you like I'll be going over that in a second, but it's like everything's provided by Google. You just have to like give it some videos of the things and then like highlight the objects you want it to detect, and then it'll do like all the processing and calculations for you. Yeah.
you like scan them, it tells you like the exact location that you are on the field. Is that like
Well, yeah, you can actually well, it's like not 100% accurate, right? But it's actually pretty accurate. Yeah, so they're going to be like most of the time they're going to be placed around the field. For example, in this game, in this season's game, we had like April tags on yeah, the pixel boards. So some teams use that to like accurately like move to like the boards. Yeah.
what would vision how the robots use?
Like so you typically use vision and FTC to like for one like navigation too, but also when you want to like pick up these game elements, for example, like last year we had like the hexagonal pixels, which were the game elements. If you want to pick them up accurately and then move to them accurately, if you use vision incorporated with that, you can like find out where it is, like relative to the robot and then drive to it. Yeah.
Is there
Well, yeah, so I'll be going all over all of this stuff in a second, so hold on to your hold on to your questions until the very end of like the slides. Is this like, yeah, open source means it's open to the public, basically. Yeah.
are some libraries not open?
Yeah.
So
They're
what
quite
are they open to?
They're open to nothing.
Yeah. Okay, anyway. So camera. So you're allowed to have a USB video cloud camera for robot vision. So a lot of teams are going to use like the Logitech camera. First represents like these three models, which are B270, B310, and C920. So Rev control hubs themselves don't have like a built-in camera, right? So what you can do is they have a USB port, so you can just connect the camera to the USB port and then mount the camera on your robot. And like motors and servos and basically everything else, they must also be added to the robot configuration. Yeah.
First of all, do the three models have anything different in particular?
I think, yeah, some
Or are they just updated?
yeah, no, it's like the range, like it's the range, right? So some are like narrower and some like provide a wider view. I'm pretty sure some are like more expensive than others too, right? Yeah.
Also, where do you find these? Are they also integrated?
Yeah, you just like buy them online anywhere, I guess. Yeah, Amazon.
Sure, these not go with the camera. Those things do not go with us.
Yeah.
You can buy them from any major tech store.
Yeah, sure. No.
Yeah. I mean, no, I'm pretty sure most cameras are allowed by FTC, but like,
Yeah.
Yeah.
It was like regular USB webcams.
yeah,
Very good. No, it's only like
it's like
$50
I
probably.
guess. I saw like up to like 100 for some.
There's also like 30 if you go
the
up
first one's like $30. The second one's like 45.
Okay, just say it.
Oh, okay. So like you said, there's three types of cameras. This is the C727 is the main one most teams use because it's the cheapest and most broadly available. And then you can go into these two kinds of cameras depending on the task. Like for this year, what I use this one because I need a wider vision view for autonomous. But if it doesn't really matter, I'm just picking which one fits in your budget. Yeah.
Does the like TensorFlow open source video thing and the
Yeah,
third one, do this all work with Roadrunner?
like together with
Yeah.
they're like dependent, like independent.
Ideally, like try to only use Logitech cameras because most of the things based out of FTC SDK is like
Yeah,
usually made for it, and some people during inspection are like really iffy about off-brand cameras.
Oh, Yeah. Last question.
So, what is the maximum amount of camera? So, does it phrase it? If it work like your dress, like
I think it was like two cameras or something. But honestly, like you can some teams have like one at the front, one at the back. But a lot of teams like just use one.
You can only have two because I see on the college.
Yeah. Oh wait.
So we have two.
Previously.
Okay, so TensorFlow, right? So TensorFlow's machine learning technology, it's designed by Google. So in this system, they were used to detect the pixel. So detection for the white pixel was actually already provided CK, I believe. But for like other game elements and other colors, you had to like train yourself. And in FTC, we use TensorFlow Lite, and yeah, they can be used to detect game objects as well as team elements. So the next slide, I believe, is like how to implement it, but that's like not really important right now. So the purpose of this entire like slideshow presentation is to give you a feel for what is available to you in FTC. And we're not going to go over too in depth into any of these because that would take like forever.
Basically, like this, you like
So yeah, you can initialize it and you can use it.
yeah.
Great. And if you want to train your own models, you can use the FTC machine learning toolchain. And basically, you upload short videos of the object. So you take videos at like various angles, and you upload the videos to the cloud, I believe. And the model is trained using Google TensorFlow Cloud Training. And yeah, here's an example where teams use TensorFlow to. So on the top right corner, top left corner, there's a duck, and that was their team game elements. So they used TensorFlow in order to like locate it. Yeah. Okay, so a note about TensorFlow. So TensorFlow is used for detecting patterns normally. So when you're working with geometric objects or pixels, which may look like blobs actually in some like angles, TensorFlow may not like be the most accurate because it's like not great for detecting geometric shapes or colors. So most of the time, FTC game elements are going to be like these pixels, right? They're not going to have like pattern and they're going to have a shape. So that's like the downside to TensorFlow because it doesn't detect it all the time. However, as you can see, it's still pretty accurate. Yeah, it's used by a lot of teams because it's really useful. Yeah. So April tags. April tags are like a 2D barcode or they're black and white images that are placed on the field. And the good thing about them is that like their shape and size is really consistent, so they can be detected as like wide angles, and they're also black and white, so they work really well in a variety of different like lighting. As opposed to like TensorFlow, for example, it's going to be impacted by the lighting. If the lighting's like really dark and there are like a lot of and there are a lot of shadows that might impact like how the model sees it. But April tags are going to be like a lot more consistent. And in FTC, April tags are often used for like pose estimation, which is like where your robot is relative to other things. Yeah.
It's just overall for this concept. Which, because you guys are extinct, right?
Yeah.
So which one do you guys use, or which one would you recommend?
So it actually, the reason we're going over all these is because it depends on the game. So it depends on the current season. So if for one season, it might be like really, really useful to use April tags to locate the objects. This year, there were April tags on the backdrops, which were like scoring zones, but they weren't like completely necessary. So some teams like just didn't use them at all. But like for example, like TensorFlow too, like some teams don't like in some seasons you don't really need TensorFlow as much as other seasons when they're like the game elements are also different. So it's all dependent on like the current season. Yeah.
Where April time is replacing the robot.
So the April tags are placed on the field actually, and also on like the game elements. So if you had an April tag on the robot, that wouldn't really help because the camera would it wouldn't like really help, right? Because the robot's moving around. But let's say you have an April tag on this wall, for example, right? And the robot's moving around. If you have a camera pointing towards that wall, with April tags, you can like find its location relative to the April tag. And you already know where the April tag is on the field, right? It's given to you, like a lot of the time. So then you'd be able to like track where your robot is. And if the April tag is on like the game element, then you would know where the game element is. Yeah, it would. Yeah. Yeah.
Set location, right?
Most of the time, unless they're on game elements. So like,
On the given, so every team can bring their own April tag. Like,
oh, they're just set up on the fields. Like by game element, I
every
mean
team
like,
has.
yeah. So yes.
So
Wait, I'm gonna move on now if that's okay. Okay, so this is stuff we already went over. It has 100 pixels, so it's 10 by 10. And the family that we use in FTC, which is 36H11, has 587 unique codes. So there's a variety of options. And yeah, a little bit more. You can like measure like the x offset, the y offset, and like the angle offset too. So that's like how you do it. Okay, moving on very quickly. OpenCV is it stands for Open Source Computer Vision Library, and it takes a frame from the camera, which is like a photo from the live video, and it makes a matrix for each of the color values at every pixel. They do. Open source computer vision library. Also, the slides will be provided at the very end, so you don't need to type everything. It's used for like let's say you want to detect like a color that's see if the color red is on the left side of the camera or on the right side of the camera, then you could do that. Yeah, quick question.
You should like listen.
I have a wrapper from the C++ What is that?
Oh, it's like usually I think it's used for C++, but in FTC, we type most teams type in Java, right? So it's like it's like basically you're typing in Java. Basically, it's like yeah. We use Java to like control programming C++. Okay, so code. This will be provided at the very end. Huh? Yeah, we'll be providing the slides at the end. And so the last one is Vision Portal, right? So Vision Portal is used to implement all three of these at once. And it allows for all these three different vision processors to run at the same time. And so it's a really neat way to organize all of them. And as you can see here, this is actually using, so you can see the April tag, so it's using the April tag. On the right side, it's detecting the volt, so it's using TensorFlow, I believe. So yeah, it's used for a variety. It can like combine them. It can use them together. Okay, and the last note is the team game element, which I mentioned a few times before. Basically, teams have an option to use a custom game element in every match, and the reason for this varies on like the season. But there are a few rules. Like the team props has to be either you have to have a blue one and a red one, and it has to have your team number on it. Yeah. Yeah. Yes. Yeah, that is required actually. So there's game manual one, which is like all of the instructions, all of the rules for all the games and all the robots. And it's a really long document, but it has all the rules for FTC and they update it every year. Yeah. Yeah, side plate like those. So what was your question? they're not required, but they're helpful for like protecting a robot. Also, it looks a lot cooler. So
One last question. Do
yeah,
all the seasons have you talked about the gaming elements and
team game elements.
right?
Yeah, I believe that all games every season do have the option to use like a game element. The plus side of using this is in most games, there's some way to earn more points by using your team game element instead of just the game elements provided to you.
And they're either blue or red.
Yeah, because the teams are blue or red, so they have to match your team color.
Why is it on shape default?
Okay. Yeah. Okay. We're providing the slides at the end, by the way. Okay. So now we're going to go on to hands-on time. Go into the hands-on time. So the agenda, the numbers are wrong because coding the claw is like um easier than coding the drivetrain. So we're going to go over that first. But basically, we're going to be programming a claw, and then we also have 4 claws for you guys to test out uploading your code to onto the claws, and then controlling them with your computer. So first, I'm going to
Talk to them about resetting the servos.
yeah. Wait, do you want to do it or should I?
If you know how to do it, yeah.
Can you?
Yes.
One of you guys. Yeah. Okay. I'm gonna be doing some live code first, basically, and then you guys can try it out on your computers. Wait, Albert. Okay, so before we do anything like connect to the robot or connect to the driver hub, control hub, we're just gonna do all the code in Android Studio first, and then I'll walk through like the logic and the process, and then and then I'll go over uploading it, and then you guys can try uploading so many just in case.
They're gonna come and code the on the robots.
Yeah.
Okay, so should we set up?
They're gonna do
So
the
we can all use this. Is that okay? Okay.
Well, sure, let's spread it.
Yeah, 8 champions. If you read it over,
Are they also building the cloud? Or they're just programming the cloud. They're just programming. Okay.
Wait. You know how
Okay, so we're gonna go over code right now. Can you not like
no more time for the description.
okay. So first we're gonna be going over like controlling the claw. So this is not exactly what you might actually do with a robot, but it's an example of how you'd control a servo to control like some mechanism from a robot.
Hey.
Yeah?
Okay.
Do you have questions?
What's up?
So can everyone open up their Android Studio And if you don't have it, just like follow one, maybe like tag on to someone next to you. So first, you guys should see a team code section on the left hand side. So it might be under FTC Robot Controller Master, or it might just be what you see like on my screen under FTC Robot Controller. But open up team code, then open up Java because that's where we're going to be coding. So team code, Java, org.first inspires FTC, which should be the only option. And then there, if you right click this option, and then hover over new, you should see Java class. And if you click Java class, just name it uh, claw. I guess claw. Yeah. So if you guys remember at the beginning, I talked about op modes, right? So you need to create an op mode in order to execute your code. So in order to create an op mode, we're gonna do this thing called extends linear op mode, which you write after the name of your file. So I'll show you what I mean by that. Extends and then capital L, I think linear op mode. And okay, it says it's red right now because I haven't done something called importing the class. But if I hover over it, I think, and then I click import class, it should automatically add it. And if you guys don't have like the red squiggly line, or you guys don't have the option to import a class, that means you guys haven't either you haven't built it with the build thing that I explained earlier, or you haven't like set up that SDK properly. So try copying. So when you should get the default code without the extends linear op mode, and then if you copy that over, if you write extend linear op mode, it should give you the alternative as that slot. Wait, the package should already be there. Oh, we're doing plot for. So just try to copy what's on my screen right now, and I'll do my best to like explain what's going on. Does anyone have any problem or technical difficulty?
What do you mean?
It is 4. It's 3:52.
So we have what till 5, right?
With an hour.
An hour. Okay. Okay. Wait. We can actually add that. I don't know. Not myself. 1 because I would ask you, right? Yeah.
Yeah, definitely not because you want to.
Actually, not 100.
Software is so painful. Yeah. So we're gonna move forward. Maybe if it doesn't work for you, I'll be explaining the code up here, and then we're gonna break off into groups. So there's probably gonna be at least one computer balance. Okay. So this is giving me a red squiggly line because we're required to have a function, or method.
Most people are dumb.
Most people are done. Okay.
Just copy the code, bro.
Okay. So first we want to like get the servo, right? So we can do servo like claw is equal to um hardware.
No. Do not initialize it before you run the up. You just hit super plot and then initialize it.
Why is it in there? Oh, wait, I'm sorry. I thought it was in the method.
Bro. No, you initialize servo plot. You initialize servo plot and farming down. Clan.
And then you can add the class by hovering. Oh, this is so hard, actually. And this is the name you're going to be putting in like your configuration. So let's do like servo class something. And then so we're gonna do while op mode is active. And this means that while the program is running, we're gonna be doing something. And we can set the position of the servo by doing claw dot set position. But we would need some number, right? So the goal is that we want to change this number when we want to. So for now, I'm gonna put in position, let's say, and then up here, I'm gonna write public static double.
We had a public final.
Please stop. Position. And I'm not. I'm gonna set it equal to 0.0 for now. But
It's not that email. Want to change it?
and it's static because we want to change it later on.
Just let me go. It's gonna let it down. Let's think this locked over.
And so another thing we want to make sure is that it's actually in the range, right? So we want to make sure that position is greater than or equal to -1 and less than or equal to 1 because we have to make sure that the position we're setting it in is actually in the value. So let's do like if position is greater than or equal to -1, and this is like how to check and capital P. So if it's inside of the range, then you do this. Then you set the position. Oh my god, it's so hard. And all this code should be on the handouts provided to you on the table. And the last thing is that we want to make sure that we can see it in the driver station, the driver dashboard. So we want to add at teleoff, and then import the class as well, and then also add config at the top. And config means that we're going to be able to change the variable that are public static. And so the config over here requires the dependencies that you added before the com.acmodal added or something. And you need a semicolon. That could be it. Public static. Public basically means that it's public. You can access by like anything, like other methods. Static means in this term in this like context at least, static means that you can change it in the FTC dashboard, which is going to be important when we're like testing out the servo and moving the clause. Okay. Pass out the clause now, but
The clause.
yeah,
So we should lay them out somewhere and have them come up like
yeah, sure.
Why do you have to config on
Yeah.
So these two books, they already have drivetrain. Find here.
So the config is used without the config, it doesn't open up a menu on dashboard to change the values that are like static. Yeah. Shoot, I don't have a picture of the dashboard, but like
Open it, bro.
I have to connect to the
oh, it's chronological variance?
yeah. So for yeah, just like copy the code over if we're not calling.
Or it's connect to
Yeah,